A prism works by using refraction, the bending of light as it passes from one medium to another, to separate white light into its constituent colors, a spectrum. This occurs because different wavelengths of light bend at slightly different angles as they enter and exit the prism. Here's a more detailed explanation. 1. Refraction. When light enters a prism, like glass or plastic, it slows down, causing it to bend, refract. 2. Wavelengths and colors. White light is made up of a spectrum of colors, each with a different wavelength. 3. Bending at different angles. Different wavelengths of light bend at different angles as they enter and exit the prism, causing them to separate. 4. Dispersion. This separation of colors is called dispersion, and it results in the formation of a rainbow or spectrum. And 5. Example. Imagine a beam of white light entering a prism. The red light, longer wavelength, bends less than the violet light, shorter wavelength, causing them to separate and create a rainbow pattern. In summary, a prism separates white light into its component colors by using the principle of refraction, where different wavelengths of light bend at different angles as they pass through the prism's material. This video demonstrates how a prism works to create rainbow colors.
But it can be expressed as a sum of a bunch of clean sine waves, each one corresponding to a pure spectral color. So when you shine white light into a prism like this, all those different components get refracted by slightly different amounts, causing this iconic separation of the pure rainbow colors. To really understand how a prism works, you see, the standard explanation, what you might hear in a high school physics class, for example, goes something like this. When light enters a medium, like glass, it slows down. If a beam of light enters this glass at an angle, then a consequence of this slowdown is that it bends a little bit. Or, using the lingo, it refracts. What's going on with a prism, then, is that the specific amount that light slows down depends a little bit on its frequency. Now, most of the light that you see is not a clean, pure sine wave. In particular, the white light coming from the sun is not a clean sine wave. It's something much messier, but it can be expressed as a sum of a bunch of clean sine waves, each one corresponding to a pure spectral color. So when you shine white light into a prism like this, all those different components get refracted by slightly different amounts, causing this iconic separation of the pure rainbow colors.